Like all other protocol, OSPF also supports summarization, but the special here is you can do summarization for the external routes separately, and we call it as ASBR summarization. And this summarization is done on the ASBR itself. When you do this, what happens is type 5 LSA will be reduced, because type 5 is the one which brings the external routes. And now when you want to summarize the networks that belong to the same area, then we do on the ABR of that area, and we call it as ABR summarization. We cannot do anywhere else, only on the ABR. The first command on the top that you see is for the ABR summarization. The below one is for the ASBR summarization. So here is an example. To summarize from 32 to 64 in area 1 network. Area 1 network has got starting from 32 to 63. So you start from 32. You start from 32 in router 1. Area 1 is the command. You should not say area 0. Area 1. Start from 32 and next to 32 means 255 minus next 31. 32, you start from 30, count from 33 onwards. So 255 minus 31 is 224. This is summarized now and sent. Likewise, area 0 has got network starting from 96 to 127. Again the same procedure, starting from 96. 255 minus 31. Now do the same thing and then you will get a summarized route. You may try this later in your home. Let's move next. See, here is an example for route summarization. ASBR. We did this. ASBR summarization is summary address command, not area range command. Next. There is a command called default information originate. This command can be used to generate a default route to all the inside OSPF running routers. Listen, you got ISP here, and this is the edge router of this organization. We may be having many routers, all of them are running OSPF. So what I can do is I can ask OSPF to generate a default route and advertise to all the OSPF neighbor. Repeating again, we are not going to do anything for this. We are just using OSPF to do this. We are not going to go to every single router and write a default route. No, we are not. We are going to use the default route dynamically injected. Let me quickly show you this demo. So when you have default route dynamically generated and sent, all the routers inside will use the default route and come to R1, and R1 will send it to internet. For this, what I should do is I should configure this command under OSPF. When I do that, a default route gets injected. What LSA type it will be? Type 5. The default route distribution is not by default, so you have to use this command if you want the distribution to be. But you need to have route to your ISP as a default route. Only then this command default route can work for you. Even if you don't have a default route towards ISP, if you want a default route to be advertised, then you need to use the keyword always. Normally this command advertises 0000 default into OSPF networks only if the default route is already exists in the routing table. Very important. That is what I said. R1 should have a static default route written by you. Only then this command default information originate can advertise a default route to every OSPF routers. Even when you don't have a default route, if you want this to be advertised, then you need to use the keyword always. What does that mean? Even when the default route doesn't exist in the routing table, you advertise it. Let's quickly go and do. Now in this topology, if you see, there is an ASBR. So router 2 is like an internet for us. Let me change the symbol for you so that it will be more clear. Symbols change, symbols change, symbols change. So this is an internet for us. Our testing networks, or this one network, we should ping this route, we should ping this destination without any route in the routing table inside OSPF domain. Let's see how to do it. Right now what is actually happening is we have done redistribution from RIP to OSPF. In the previous class for the summarization, we did that redistribution. I'm going to remove that redistribution. Before removing the redistribution, I'll show you how the routing table looks in router 8. We will have all the routes of the RIP network. The internet. RIP is like internet for us. Because we have summarized, we will not have all the routes. We'll have a summary route. So let me go and remove the summarization. On R3, we did summarization under OSPF. The ASBR summarization. Show, run, section, router. There is no OSPF. So we did not do redistribution here. Show, run, no. Show IP protocol. We have RIP. But I don't see any redistribution. But I see redistribution. No, this is not. We don't have any redistribution done. I think I didn't save my configuration. It's okay. It's okay, we don't want. What we'll do is we'll write a static route. See, show IP route. Right? We have this route. I don't want RIP here. I'll remove RIP. No router. Gone. Show IP route. We don't have any route to this one is coming from other area. This one, no. So don't focus on this. We don't have any routes to reach 1.1.1.1.5.1 and so on. There is no RIP running here. Okay, even on router 2, the internet, I'll remove RIP. No router RIP. I'll just write a default route for replying to the traffic, for the return traffic. Send the traffic by F0/1. So this is ISP using this default route to reply to you. Now what is next is, listen, R8 right now cannot ping 10, sorry, 1.1.13.1. It cannot ping this because we don't have a route. We don't have any type 5 because we don't have ASBR, show IP OSPF database. You see, this is type 3. Only type 3 is there. There is no type 4, type 5. So what I do is I go to router 3 now and write a default route first. IP route, any network, any subnet mask, go to ISP. What is ISP? ISP is via F00. I said go via this path. As a result, from R3 I should be able to ping now 1.1.11.1. It's pinging. R3 can ping because of the default route. But can R8 ping? R8 cannot ping. So what is needed is route. What we are planning to give is, we are planning to give a dynamic default route using OSPF. Currently, show IP route, you don't have route to reach 1.1.2.1, 3.1, 4.1. You see only this one, which is coming from router 1. I don't want this to confuse you, so I'll go to router 1 and remove that loopback. No interface loopback. Whatever. Well, let me check. Do show. This loopback 0 I am going to remove. No interface loopback 0. Boom. So on R8 I should not see any routes. Should not see any routes starting with 1. There is no route starting with 1. So we need a route. R3 can ping because I got a default. Yeah, I got a default route set pings. Now, when you have a default route, you can use this command under OSPF. Router OSPF 1 default information originate. You don't need to put always command. Why? Because I got a default static route. Now you see show IP route. You see there is a static default route which we already wrote. And now I have used the default information originate command in OSPF. As a result, when I check the database R8, same, sorry, not R3, show IP OSPF database, I see a default route advertised from here as type 5. As a result, if you go now to router 8, this ping will work. How is this possible? What magic is this? How can router 8 ping this? It is because of show IP OSPF database giving you the default route as type 5. You got ASBR. We did not have redistribution configured. We did not do the redistribution, but still, it is ASBR because it is generating a default route in LSA type 5. Show the routing table. You can see external means type 5 default route. See, you can ping any internet without learning the precise route. Just one command, default information originating, can bring a default route to all the areas and every router in that area. How wonderful is this? Now, in case if you don't have this default route in R3, if you don't have this default route, it won't work. To make it work, you need to go under router OSPF 1. Along with this originate command, you should say always. So when you put always, even when there is no default route, OSPF can advertise a default route to the inside routers. Yep. So I hope I made things clear. Any question?
No, sir.
Alright. Do this and see, Many of us learn these things. These things are wonderful in production. But we don't try here. When you don't try here, you will not recall these things when you need it. You will not be able to recall.
Okay.
So now let's move on to the next concept. So we just did this and we verified it is working fine. And you see the default command can also be used along with the cost. You can also set metric, which I did not do in my example. If you have multiple ASBR, and see if you have multiple internet connection and you want to prefer this internet service provider, if this one fails, you want to use this, then what you can do is you can say default information originate, small metric on router 1 and big metric on router 2, so that all the routers inside will prefer R1 as a exit. Smaller the cost, better is the route. Only when this fails, only when R1 fails, goes down, R2 will be used because of the because of the metric. Is this easy to understand, or you want me to do? Not necessary. It's easy. Easy. Right? You got two ASBR, means two ASPs are connected to your OSPF network. This is the procedure. So one last chapter to go, which is called Stub. OSPF special area types. OSPF supports, or OSPF has, in Cisco routers, OSPF have got 4 special areas. In the non-Cisco, only 2. In Cisco, 4. What are they? Number 1, stub. Stub is one special area, which is Cisco's as well as industry. So you can see in both. But totally, the word totally, if you see, it is not from industry, it is from Cisco. We got stub area, totally stub area, and then not so stubby area, not so stubby area, and then totally not so stubby area. These are the 4 special area types. So this totally, I said wherever totally comes, it is Cisco. You will see only in Cisco this one. But this one is seen with everyone. Not so stubby area and the stub. Is seen in both Cisco and non-Cisco. Totally stub and totally not so stub is seen only in Cisco. Only 4 things: stub, totally stub, not so stub area, totally not so stub area. This one and this one is Cisco only. Only on Cisco router you can see this too. So Cisco router has got 4 special areas. The other vendors will have only this and NSSA. Now, stub and totally stub. And the other 2 we'll see in the next class. So going back to the same topology, I'm going to make area 500 as stub. What is the use of this? If you make area 500 as a stub, LSA type 5 will not be allowed inside. That is what stub. Then will I be able to ping those RIP routes? Yes. How? A default route will be given. Listen, right now you got a default route provided by type 5 LSA. But when you configure this area as a stub area, type 5 is blocked, which means your present output shows you are learning this default route as type 5. E means what? Type 5, no? And you can also check it here. Show IP OSPF database. Type 5. But when I make this area as a stub, I will not get any of this. Instead, I will have a default route here in the summary LSA given by R1. Understand? Earlier the default route was given as type 5 by whom? By R3. But when you make area 500 as a stub, R1 will give you the default route. You want to see that? Let me show you. Router OSPF 1, area 500 is a stub. You need to configure this on both R1 and R8 because the neighbor will go down now if you don't configure. On R1, router OSPF 1, area 500 is stub. Now the neighborship will come up. It has come up already. Now let us go to R8 and check. Earlier when I was checking the routing database, I showed you type 4 and 5. Now no type 4 and 5. In type 3 itself, you got a default route. This is not because you written default information originated on R5. No, not because of that. This is because this area as a stub. This is because we have configured this area as a stub. R1 will generate this default route. Now you see, show IP route. You got IA means, given by type 3. Type 3 is giving you default route. Using this, it will go to router 1 and you can ping the external.